All right, welcome to section 1.2, transformations and functions. This is recorded live during my period 7-8 class today. Just wanted to let you know that this little chart is all about your transformations. Now, anything to the outside of a parenthesis or absolute value or square symbol is going to signify a vertical movement. Okay. That's one of the things that we've kind of talked about in class is how vertical and horizontal movements are the main things that we need to be concerned about. It doesn't just mean that we're going up and down and left and right, as you can see from those very first two, but it also means as well that with vertical, if you have a number on the outside, can just kind of show you where I'm looking in this chart right now. If you have a number on the outside of whatever your function is, if it's greater than 1, it's a vertical stretch. If it's less than 1, it's a vertical compression. Why this is important, and this I think is the most difficult thing to wrap your head around, is if your number is on the, if your number is on the inside, it's the exact opposite. So if your number is on the inside and it's greater than 1, it's a horizontal compression by a factor of 1 over that number. And if your number is between 0 and 1, then it's a horizontal stretch by a factor of 1 over that number. So here's what I'm kind of looking at for an example. Say, for instance, I had like y is equal to 3x. This would be a stretch. But if I have y is equal to 3x, this is a compression. This would be by a factor of 3. This would be by a factor of 1/3. Not confusing at all, right? On the other side of things, if I had y is equal to 1/3 x, this would be a compression by 1/3. But if I have y is equal to parenthesis 1/3 x, this is a stretch by 3. Isn't that fun? I know, you guys lie when you say yes. I appreciate the humor. All right, so we're going to get into the correct order of describing multiple transformations. When we're writing these transformations, anytime that we have a multiplication or a reflection, we want to write those first. And then after that, we can write our addition and subtraction. I have 10 example problems for you today. It's not going to take super long, but I do want to show you the differences between some of these different types of problems. So here's example 1. Okay, example 1 says that our original equation is the absolute value of x, and then our new equation is the absolute value of x minus 3. What happened? What's the transformation? Which way did I move? Mason? Where? Something to do with 3. That is correct. That's the new part. Down. Yeah, it should be down. So we're going to say that this is a shift. Yeah. If it's on the outside, yes. If it's on the inside, it goes right. So here's what I mean by the difference between those. This is a shift down 3. If I was going to say that it was shifting right, it would look like this. This would be a shift right. Okay, so there is a little bit of difference between those two. You don't have to write that second part there, but that's pretty much it. All right, take a look at these next ones. Next example here. We started with x squared, and now we have x plus 2 squared. So what type of movement occurs? Shift left 2. Good. It's on the inside. It's plus. This is a shift left 2. Anything on the inside makes it horizontal, meaning it moves left to right. Anything on the outside means it moves up and down or vertical. All right, I'm only looking kind of like the old highlights books where what's the difference? I'm looking for what's different. So if you look at example number 3, the square root of 5x now turns into 2/3 the square root of negative 5 times x minus 1. I would like you to help me describe the transformations that are new. The 2/3, the negative, and the negative 1. Now when I'm doing this, because this first off is on the outside, this is what we call a vertical compression. It's a multiplication to the outside that is less than 1. It's by a factor of 2/3. Okay. By a factor of is BAFO. That's just my shorthand. Okay. So anytime you see that, that just means by factor of, and you can use that as well in your notes. The negative sign to the negative 5 doesn't mean that the 5 is necessarily negative. It means that we're going to have a type of reflection. Because this reflection is on the inside, it is actually what we call horizontal reflection, or a reflection over the y-axis, something that we didn't talk about yesterday. All that means is that if I have a figure that looks like this, I'm reflecting it over, and the new figure would be on the opposite side of the y-axis. Last but not least, I've got that minus 1, and it is on the inside, so that would be a shift right 1. Good. Okay. I'll leave that up there for a second, and if you guys have any questions, otherwise I'm going to move on to example number 4, because I want to show you what a horizontal. How did I know it was a reflection? The negative to the 5. Anytime that you see a negative that's going to give a multiplier, it's going to be some type of reflection. So whether it was maybe the square root or negative square root of x or the square root of negative x, those will give some type of reflection. If it's on the outside, it's a reflection over your x-axis. If it's on the inside, it's a reflection over your y.
How did you know that it was a inside reflection of y?
Inside is a reflection of y.
Yeah. How did you know it was a vertical?
How did I know it was a vertical compression? The 2/3 is on the outside of the radical symbol. So the radical symbol, think of it as like anything that's on the inside of that radical symbol is going to be horizontal. Anything to the outside is going to be vertical. All right, example number 4. We started with the square root of x. We're ending with the square root of 3/4 x plus 2. The plus 2 is on the outside. Here are new movements, 3/4, and then plus 2. And this is a perfect example of a stretch compression that is horizontal. This is a horizontal stretch by a factor of 4/3. But wait, Mr. Stewart, we just had this other one up here that had a 2/3, and you said it was a compression. When it's vertical, it's a compression. But when your number is in between 0 and 1, and it's on the inside, it's now called a stretch. And whatever your number is, you're going to have the reciprocal of it as your factor. That's the most confusing part of the horizontal is the multiplication part. So this is actually a horizontal stretch by a factor of 4/3. And then because that 2 is on the outside, it's a shift up 2. see if you can do example number 5. Take a minute and just kind of look at the two new things in it and see if you can figure out what those two transformations would be. Give you about a minute in class to do that. If you have to, you can look at that chart for now. For example 5, you saying? Are you looking at example 5? So it'll just mean that you have two different things going on. So you'll label the negative as one thing and then the minus 2 as another. If you want to go on to 6 and 7, you can. You know what, 5? Why don't we go over 5 real quick, and then you guys can do 6 and 7. On 5, what does a negative outside mean? Justin?
Reflection of the x-axis.
Good. Okay, reflection on the x-axis. And then the minus 2 on the inside?
Shift down to.
Not down.
Oh, sorry, shift right to.
Shift right to. Good. All right. If you'd like to, try 6 and 7. Now, if you take a look at 6, it already has that 2 included. So really what I'm looking for is, do you know what these movements are? And then on 7, it starts with the x squared, the 3, and the 4. We need to figure out what those types of movements are as well. So go ahead, take a minute or two, see if you can figure those out. If you need to, you can still use the chart.
So for 6, since the negative is going under with the 2, not the x, what does that mean?
It's still a reflection. Yeah. Bless you. All right, the negative. Let's take a look at that. The negative means what? What type of transformations occur? Joaria? Good. Good. Reflection over x-axis. All right, how about the minus 2 on the inside? Anyone else want to give it a try? Go ahead.
Move right to.
Good. Shift right 2. And then the 1, Brady? Up 1. All right, and then example 7. What does the 3 mean? Yep.
It's a stretch by 3.
Good. Vertical stretch by factor of 3. And then the other one should be the shift up 4. So we've taken a look at going from one equation to the other. Now we're going to work a little bit backwards on these. on 8 through 10, and this is all we're going to finish up doing today. 8 through 10, I'm going to give you the original equation, and then in words, I'm going to express the different types of movements that are occurring. I'd like you to create the new equation. So I'll show you how to do it with example 8, and then a 9 and 10, I'm going to have you guys kind of try. The graph of f of x is equal to the square root of 3x plus 1, vertically compressed by a factor of 1/5, and shift up 3 units. First thing that I want to do is I want to take a look at this. It says vertically compressed by a factor of 1/5. It's a vertical movement. That's going to be on the outside. Shift up 3 is also going to be on the outside. So I'm going to rewrite this starting with f of x. And I'm going to put in red my newest. So I've got 1/5. Thank you. And then from here, I'm going to go to the square root of 3x plus 1. And then I've got that extra shift up 3 at the very end, so I'm going to put plus 3. And that should be my final answer. So example 9 might be a little bit tricky, but try it first. See if you can create the new equation. And then from there, if you want to try 10, you can go ahead and do so. It's totally up to you. All right. So we've got a horizontal stretch by a factor of 6. That should go on the inside. We've got a reflection over the x-axis. Okay, that's going to be on the outside. And then a shift down, that's also going to be in the outside. So I'm going to start with, I've got the 7 and then the absolute value of x. This is going to create a negative because of that reflection. 7. Absolute value. Now here's where it gets tricky. Horizontal stretch by a factor of 6 is actually going to be written as 1/6 x. And then the shift down 2. So minus 2. So if you got the 1/6 part, you're doing pretty good. Good. Yeah, that 1/6 is a little bit tricky. The reason that it's flipped again is because over here, okay, if it tells you that it's a stretch by a factor of, whatever that number is, it's horizontal. It's actually going to be the inverse of that number. All right, and then last but not least, example number 10 here, we start with x squared plus 5. It's vertical stretch by a factor of 2. So that's on the outside. That means that I'm multiplying by 2. And then a shift right one is on the inside. and that would be doing the negative 1. I'm going to rewrite this as f of x equals 2 is going to be on the outside, parenthesis x minus 1 squared plus 5. Even though there's not parentheses there, when we're creating that shift left and right or doing something on the inside, we can automatically put parentheses into our equation.
So does it have to always be x? Like, why did you put a square on the outside?
I put this squared on the outside of the parentheses because of the fact that the shift right one has to be in, like, on the inside of the square, technically. The square acts as kind of like the buffer for like adding and like what goes on the inside compared to what goes on the outside.
But wouldn't that just make it a positive? Like the square would be positive?
It's you're thinking of it. If we put a number in, yes, it would, but we're not putting any numbers in. We're just using that. It's not like we're solving it. Let me put it that way. Yeah. The only reason I put the minus 1 is because it's a shift right, which then makes it so it's the opposite. Yeah, I know the horizontal is a little tricky. All right. That's all I've got for you.